Thank you for joining us this morning on our webinar. This is part two to using removable media functions. So last week's part one is up on the webinar section of our website if you do want to go back and watch it. It's roughly about 20 minutes of presentation, and any questions at any point, don't be afraid to put them into the questions panel and we'll get to them at the end. We'll get started.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda. We'll begin with a quick review of removable media functions part 1. Then we'll discuss 4 removable media logic functions: the read removable media function block, the read removable media structure function block, the write removable media function block, and the write removable media structure function block. We'll have demonstrations throughout, and as always, we'll finish with a live Q&A session. We'll start with a quick review of the OCS Removable Media functionality. All OCS models support removable media, and that's either microSD, which all OCS units have, or USB flash drives, which only some OCS units have. All OCS products utilize the FAT32 file system with an absolute maximum of 2 TB in volume size. There are many built-in functions that utilize media. There's data logging and report writing. You can save and load your program. You can make and load a clone. We have a removable media graphics object, and you can grab screen captures. There are also removable media function blocks available in Logic. Removable media status is available through %SR status registers. There are many codes that let you know your status. We also discussed the removable media graphics object, which allows the designer to provide the user with controlled access to the removable media drive from the OCS at runtime. The designer can determine what starting directory will be displayed to the operator and what functions are available to the operator. We covered 3 different logic functions for file manipulation. These were the rename, delete, and copy function blocks. All these functions can be used on the built-in microSD drive or the external USB drive. We also have wildcards available that you can use to embed special characters, such as the date or the time, into your file names. Now we'll discuss the read removable media function block. This allows you to load data from a CSV file into OCS variables. There are several parameters required when you're configuring the function block. There's the file name, which you can make either a file name by surrounding the name in quotes, or a variable. There's a file offset, which is the starting point within the file that you're accessing. For example, in a spreadsheet, you might want to start reading at cell number 100. So you would specify the number of cells that you want to skip, which is 99, and then you would assign a variable to it. There's a destination address, which is the local variable or register number where the data goes. You have to specify the data type and the number of elements that you're bringing in from the file. Then you assign a status variable for monitoring. Now we'll discuss the file offset that we mentioned. In the upper right, we have a spreadsheet. With an offset of 0, you will start in cell A1, the first cell. If we have an offset of 12, you count across first and then down. You would start at cell A4 because there are 12 cells before it. In a notepad file, it's the number of comma-separated values that you would like to skip. What if there are multiple data types that need to be retrieved? Each function block can only handle one data type, so if multiple data types are to be read, you need to sequentially cascade multiple function blocks. Only one removable media function block can execute at a time. As you can see on the spreadsheet, if column C was read as a boolean instead of an integer, then 3 read function blocks are required per row. Now we'll demonstrate this function block in Cscape. Please note that the dates in these videos are in American format. These can easily be changed in the system menu to suit your desired format. You can find more info on the handling of the clock and dates in one of our past webinars, OCS Real-Time Clock, which can be watched back on our website at any time, along with all previous webinars. I'm in Cscape. I've programmed this read removable media function block. We'll quickly look at a CSV file in Excel first. We want to be able to import data from this file into the OCS. Whenever we're bringing in spreadsheet data, we need to calculate the offset, or the point in the spreadsheet where we start retrieving data. If we wanted to start reading data at this point, we would skip 8 elements and start at the 9th element. So our offset would be 8. Okay, we've got a simple math expression here that is calculating the offset based on the line number. Then, once we've calculated the offset, we'll execute this read function block. This is already configured. We've got our file name. The file name must be typed in between single quotes if it is not a variable. The offset is a variable called offset position. In this expression block, we calculated the destination where we're going to place these characters inside the OCS, in an array variable called current data. We're going to be bringing in 4 elements, which are all integers. They'll be placed in current data sub 0 through current data sub 3. We also have to assign status, which we have as read underscore data underscore status. Now I'll safely eject this disk from my computer. Alright, so we're safe to remove it. Next, we'll look at my XL4 and I'll put the memory card in. Once that's done, we've got the ability to pull in data from the spreadsheet file and import it into variables. The variables are shown here. I can adjust which row numbers of data I want to bring in. I want to bring in the first row of data, so I'll set that variable to 1, I'll hit the load button, and my data changes. If I change my set to 2 and hit the load button, then my data changes again. So that is data set 2 with a P1 value of 25. So that was the read removable media function block. Now we'll talk about the write removable media function block. This is used to write data from OCS variables to a file. There are some parameters required when configuring this function block. You need to specify the file you're going to write to. There are 4 different modes. You can configure the write block to create a new file. There will be an error if the file exists. You can configure it to append written data to an existing file. If the file does not exist, you'll get an error. You have create or append, where if the file doesn't exist, you will create it, and if the file already exists, you append to it. And then you have overwrite, where if a file exists, you'll overwrite it with a new file. Then you need to specify the source address, variable type, number of elements you want to write, and a status variable. If you have multiple data types that need to be written, every time you switch data types, you need a new write function block. Only one removable media function block can execute at a time. You can handle all the data as real, so that it can be written with a single function block. However, if you want to put headers on the file, you will need a separate function block for the headers in ASCII format. Here's the example that we're reviewing today. A short test is executed on the machine, data logging 3 test parameters every scan. After the test is complete, a write block is executed to create the file and write the headers. Another write block is executed once per row to append the data to the file. You have to ensure that only one removable media function executes at a time. Now we're going to demonstrate this in Cscape. Here's my write removable media routine. So what we're doing here is after a test is completed, we're going to create a new file. When we create that file, it's also going to create the headers for the data that we are writing to the file. As soon as that's done, we'll run the data that we've stored in variables through a loop and execute one write function block per row of data. So if we have 100 rows of data, the function block is writing the data 100 times. We'll start by establishing the headers. The headers I'm using are contained within this string and are separated by commas. So I have sample, degrees F, psi, and millimeters. As soon as my test is done, I'm going to turn on a bit called create file. When that bit turns on, I'm going to execute the first write function block, which executes a create file. The file that is created is loaded in this directory, and the source of the data is the test headers data set. The end of row now flag is on, because I'm writing one complete row. And then I want to execute a carriage return line feed at the end of the row. The type is ASCII because headers are in text readable format. The number is 18, and of course I've assigned a status variable. When that's done, I have a headers complete bit which turns on. I turn off my create file flag, and I also trigger a one shot here. This is to make sure that only one removable media function block is executing at a time. Then, I will wait for the one shot to turn off before I move on to the next step. As soon as that scan has passed, now we'll start writing the row data. When we're writing row data, we need to keep track of which row we're on. We have some logic here that checks to see whether we are at or beyond the last row. If we've already written the last row, all of our flags will turn off and we'll execute the write routine. If we're not at the last row, we're going to execute this write function block. This function block retrieves our data that we're going to write for that row. It uses the same file name that we used earlier. We're appending the data and we're using real data. The number of elements that we're writing is 4, and we've assigned a status. Okay. For every row we write, we're going to increment this function block. When each row completes, it adds 1 to the current row number. For a lot of applications, you can use our built-in data logging object, and there's no reason that you have to write this function block. But if you want to do something that isn't covered by our data logging object, you can write whatever you want using these function blocks. Let's see what this looks like at runtime. I'm back in my OCS here, and I'll move on to my next screen. I'm going to hit this removable media object for demonstration purposes. This is the data we have on the memory card. I've got a test data directory here, which I'm going to delete. So I've deleted that directory. Now, when I hit this create file button, it's going to create the file and write data values to that file. It completed very quickly, and now we'll go back to the removable media. And as you can see, there's our test data directory. If I hit enter to zoom in, there's our testdata.csv file, and it's got 94 bytes of data. Alright, so we were able to successfully create that CSV file from logic. So that was the write removable media function block. Now let's look at the removable media function blocks that utilize structures. Structures are only available with variable-based advanced ladder. The read removable media structure function block is used to read data from a file to a structured variable without any type restrictions. For configuration, you have to specify a file name within single quotes. You have to specify the file extension type. Currently, we only support type CSV. You have to select the destination address, which is the structured variable where the data will be written. You have to assign a Boolean bit, which specifies whether you're reading from the start of the file or not. There's also a checkbox for whether there's file headers in the file or not. The read removable media structure function block allows you to use a single function block to read a mixture of data types from a file to a structured variable. As long as the structure has been designed to match the data types of the file, it's a seamless process. So it's much simpler than the regular read removable media function block. There are some status variable differences too. The removable media function blocks have 2 words of status, but the read structure function block has a third, which is row offset. This is a register or variable that allows you to specify which row you want to do your read from. So if you want to start at row 2, you don't have to write logic to increment that offset, you just have to set this variable to 2. Now let's demonstrate this function block in Cscape. We're in Cscape, we have one function block where we're doing our read, and then we've one rung where we're calculating a fail status bit, so this is much simpler. we've got a CSV file that we're going to be reading from called def_parm. We're going to be writing into a structured variable called machine, and let's take a look at that structure. I'll pull up my variable table here, and I'm going to scroll down to the structure area. Here's my structure called parameters. It matches my spreadsheet. It starts out as an integer with a couple of rows of real, another integer, a double integer, and then a boolean. I've created a new variable called machine that's in that parameter structure. In my function block, I specified that my variable is machine. And then here's my status that I've assigned. We're always going to read from the start of the file, so that's going to be always on. I have file headers in this file, so I checked this checkbox. Now we'll take a look at our OCS. So we're going to select the line number that we want to read in. So this is our third status register, which is essentially a row offset. So if I specify a row offset of 1, then I'm going to be skipping the first row, which is where my headers are. And then I should be reading the data into all of these variables over here. Okay, so I've set the line number to 1, and I'll hit the read button. And there's my data. The offset has automatically incremented. So if I execute this again, I'm bringing in the next row, and I can just sequentially execute this. If I only wanted one specific row, I can just set the row offset and execute it once. But if I'm going to be bringing in a whole series of rows, then this auto-incrementing feature makes it a lot easier to code. So that was the read structure function block. Now let's look at the write structure function block, which writes data to a file from an OCS structured variable without type restrictions. The configuration is similar to the read structure function block. We specify the file name and the file extension type. With these structured function blocks, we don't put the extension in the file name, we handle that with a pull-down list. The source address is the structured variable that contains the data to be written. The mode is the same as the mode we use for the read function block, which is either create, append, create or append, or overwrite. And then we also have the write column headers on the create flag. If you're creating a new file, by checking this flag, it will automatically create headers based on the names configured for that variable in the OCS. Now we'll demonstrate this in Cscape. So we're in Cscape. This is equally as simple as the read structure function block. We have one function block and a little bit of logic for status. We'll head straight into the configuration. We've named the file doc_parm, and it's a CSV type file. My source address is a structured variable called document. We'll quickly look at our variable list. We're going to scroll down and look for our parameter structure that we use for our machine variable. We're using the same structure for our document variable because we're creating a file that's structured the same way. You would normally have a different structure for the file that you're writing to than the file that you're reading from. After assigning our variable, we assign a status register. There's only two 16-bit status words like most removable media functions. We don't have the third register for row offset. We have the same modes that are available in all of our write function blocks. If the file doesn't exist, we're going to create it. If the file already exists, we're going to append it. I have checked write column headers on create, so that if we create a brand new file, we'll create column headers. Now we'll take a look at our OCS. Here is our write structure demo screen. We'll go into our removable media file and see if the doc_parm file already exists. It does. I'm going to delete the file so that we're starting fresh, and as we can see, that worked. Now let's go back and execute a write. There we go. So we created the file. Now let's take a look at it. Alright, so our doc_parm file got created, our headers were created, and now if I want to add additional rows of data to that file, I can do so by pressing the write button. Every time I press the right button and execute that function block, it will write another row of data. Here is the data that I'm writing. Now let's write the data. I'll make some changes to the data, and then we're going to write another row. I'll keep doing this a few more times, and then after we're done, we'll pull the media card and see what the spreadsheet looks like on my computer. I'm back in my computer, and I've put the removable media card in the PC. Here are all my files, and here is that docparm file that we just created. I'll open this file, and here is the data that we just wrote. Now I have the same entry in two different rows, but that's because of my own user error. So that was the write structure function block, and that wraps up the demonstration for today. Thank you for attending today's tutorial. The Q&A session will begin shortly.
Okay, nice follow on from last week. Do we have anything in? Not that I can see at the moment. So we will go back to our screen. Okay, hopefully you can all see my screen there now again. So next week we do have graphics and animation into audio. Those are the next two. As always, the registration links are all there. If you want to sign up from now, that'd be great. And we do have it detailed out for up to the end of December. So you can get signed up for all those now and you'll be sorted when it comes to it. And if you have anything else that you want us to look into or do a webinar on, feel free to let us know and we'll work on those as well. Okay, no questions then. Thank you for joining us this morning, and hopefully we'll see you again next week.